Yeah, no, he was right. They're using tomatoes, tomatoes are an acidic fruit. Um, y'all know that tomatoes are fruit and not vegetables. Well, so here's the thing. Botanically, they are fruits, but like digestively, they're vegetables. Or like I guess culinarily, they're vegetables.
Wait, I don't
Like
understand.
technically, they're fruits. So like a fruit has to do with where it grows and where the seeds are at. And like I might be wrong about this. A strawberry is not a berry because the seeds are on the outside. So it's just it has berry in its name, but it's wrong.
No, it's astrological.
It's wrong. And yeah, tomatoes are fruits. What else is a fruit that's weird?
Berries.
I don't remember. Well, I guess if a tomato's a fruit, then like a cucumber has to be a fruit too, probably. I think. What?
What about?
Oh, I don't know if we had something bad. So, anyways, so we had our favorite acid stories with tomatoes, and then I got on a sidetrack. But today we're talking about acids and how to name acids. So, what are the first two branches that come off the acid tree here? Oxyacid and binary. So we're going to have binary, which has hydrogen and some other element, and then we're going to have oxyacid, which has what and some other element? Oxygen. So those are the two things that you can combine to get an acid. And we're going to have different names for each of these. So know that most acids have hydrogen in them. Almost every single acid has hydrogen in them. The most common of which, I guess, in the lab is going to be hydrochloric acid, which has hydrogen in what? Chlorine. Yes, chlorine. And you can tell by the name hydrochloric acid the way that we're going to be naming these. Instead of the "ide," we're going to add what to the end of the non-hydrogen element?
IC.
IC or ic. So hydrochloric acid. And we do include that as part of the name because we're telling people that it's an acid. So notice they have that at the end. After the ic, they have plus acid. So binary acids is an acid composed of hydrogen and one other nonmetal like chlorine or some other nonmetal like that. So hydrochloric acid, HCl, has one hydrogen and one chlorine, and we call it hydrochloric acid. And that's the naming convention that we use. So you have the hydro plus the nonmetal stem plus the ic ending, and then the word acid at the end. Acids are not ionic compounds, but they ionize in water. And this is very important. By themselves, they are not an ionic compound. Hydrogen has 1 electron. Chlorine has 7 out of 8. When you put them together, they have 8 electrons together. They're not ions. But when you put them in water, they do ionize in water. So a number of hydrogen atoms in the formula of an acid can be found by treating each chemical species as an ion and thinking about it as an ion. For example, formula for hydrochloric acid or hydrofluoric acid, is HF. So you have 1 hydrogen and 1 fluorine. Now, moving on to an oxyacid, because we're not getting too deep into acids right now. That's actually, I believe, the last chapter in the book, so we may or may not get there towards the end of the semester. So we're just talking about naming them right now. So if it's a binary acid, you have the hydro at the beginning, the ic at the end, and then the word acid. For oxyacids, this is an acid composed of hydrogen and an oxyanion. So a polyatomic ion that also has oxygen in it. On one of the previous pages of the study sheet, you have that list of oxyanions, the chart here. That has a list of a lot of your oxyanions, and then we have the naming convention that has the per ate, ite, and then hypoite. Does everybody remember that? Those are your oxyanion naming conventions. So oxyacids are named in series just like that. The per I already forgot it because it's gone. No, it's not right here. The per, the ate, the ite, and then the hypoite. But we're gonna have a different naming convention. You can see it right here in the oxyacid branch. The very first one is gonna have the per, just like the per ate had, but instead of per ate, it's gonna be what? Per ick, because you have the ick at the end. So we have per ick, then we have just the ick, and then we have an us. So like instead of hydrochloric acid, it might be chlorus acid. So us instead of ick. And then at the bottom, you have hypo us. So those are your 4 different ones that you have here. So they have it laid out. Per ick is going to have the most oxygen. Then you go down to ick. Then you go down to us. And then you go down to hypo us. And those are your 4 different series for how many oxygens you have. They have 2 examples here. One with your actual acid, and then they have the just the oxy and ion name here. So if it has hydrogen along with the chlorate or perchlorate ion, it's going to be perchloric acid. So 4 oxygens will be perchloric acid. 3 oxygens will be chloric acid. 2 oxygens will be chlorus acid. And then 1 oxygen will be hypochlorous acid. So each of these is an acid because it has the hydrogen and the polyatomic oxy and ion. And then is this the last slide? No, we got a couple more slides. So how do we name these? Step 1, use the acid's name. Determine what ions the acid will ionize into and write the ions. Step 2, do the cross and drop. So we practice the cross and drop in ionic compounds. We're treating these like they're ions. Do the cross and drop of the absolute values of the changes of the charges, making each the subscript for the other species. So their example here, write the formula for sulfuric acid. Write the formula for sulfuric acid. So use the acid's name, determine what ions the acid will ionize into, and write the ions. So if it's sulfuric acid, it's got to have what? Hydrogen, because we know it's not using the binary name because it doesn't have hydro in it. So it's got to have hydrogen in there, and then it's got to have a sulfur, oxy, and ion. So it's got to have sulfur and oxygen in it. So their example here, you have your hydrogen, which is a +1, and then you have your SO4, which is a +2. And if you go to that chart, how would you know this? You go down to the chart, and well, actually, you're going to need multiple charts here. But on the chart we were just on, it tells you that the acid that has only the ick stem, right? Just the ick, no per in front of it, just the ick, comes from the oxy and ion that says 8, right? Does everybody see that? Ick comes from 8. So if I go back to this chart, I know I have sulfur, but instead of sulfuric, it should be sulfate. It should be the sulfate ion. So I find the sulfate ion on my chart here, and what does it say the sulfate ion is? It's SO4 2-. So that's how I kind of work backwards and get to the point where I see this ion. So I have a 2- ion and a +1 ion. What am I going to do next? Cross and drop. I'm going to do the cross and drop. I'm going to take this 2, put it down here for the hydrogen, take this 1, and put it over here for the SO4, but I don't really need to write the 1 because it's implied that I already have 1 SO4. So what's my formula going to be? I move this 2 down here for the hydrogen, and then I move the 1 over here, but I don't really need it. So it should be H2SO4, and you're going to see that in a second. Do the cross and drop. H2SO4 is what we get. Does it make sense?
Yes.
Yes. They don't really care if it makes sense for you or not. They tell you it does. Yes, it makes sense. It's not my fault. I didn't do it. I didn't write this. But make sure you do the cross and drop. I don't know that you're going to get a lot of those examples there for the assignment, but let me open the assignment up, and then you can go ahead and get started on it.
Backslide.